Hello, everyone. Thank you for joining us for one more edition of our AMS monthly AMS webinar series. This one is entitled CAM on the Cloud. It's a little bit different from our normal AMS topics. And this is some new technology that we've been working on for the past 2 years. And we're pretty excited to show it to you. And, this is something more of an informational type of webinar. So I hope you appreciate that, and we welcome any questions on this new technology that we're showing today. My name is Joe Anand, and I'm the product manager here at MecSoft. I'll be joined today by two people. The first one is Don LaCourse, our senior application engineer, who'll be talking about some user success stories using this product, this new product that's on the cloud. And then, of course, I'll be joined by Uday Honalagare, our tech support manager, who will actually be doing the demo of the product. So before we get started, a few housekeeping tips. We encourage questions from you during the webinar. There's this chat window or the questions window that you will see in your GoToWebinar dialog. And if you have any questions during the webinar, please go ahead and type it in there. And I will be in the background monitoring that. And we'll do our best to answer those during the webinar. And if we can't get to it, we will definitely do it by email after the webinar is over. And as usual, a recording of this webinar will be made available. We'll clean it up. We are recording it right now and clean it up and then make it available to all the registrants of the webinar. Okay, so today, what are the topics we're going to be covering? We're going to start with an overview of Onshape and VisualCAMc. These are the two products that we're going to be discussing today. And then Don's going to be talking about two customers who have successfully used this product and are currently using this product in production. And then Uday is going to do the demo of the product, and he's going to show how we can do 2- and 3-axis machining, and then also the associativity between the CAD, Onshape CAD modeler, and VisualCAMc, the CAM product. And finally, how do you post-process on the cloud, and how do you get it out to your machine? Okay, let's get started here. The first section is about the two different products. I want to briefly talk about these two products before jumping on the success stories and the actual demo. So let's start with Onshape. I don't know how many of you are familiar with Onshape. So Uday, if you can move to the next slide. Onshape is actually a company that was founded by the original SolidWorks team. I'm sure everybody's heard of SolidWorks, probably the largest solid modeling CAD vendor in the planet today. The original team that founded SolidWorks sold the company to Dassault and took a sabbatical. I think they took a 4-year sabbatical, and they founded this company called Onshape. And the product name is also the same name as the company. And you can think of it as SolidWorks 2.0, and that's actually running completely on the cloud. It's a professional 3D solid modeling CAD platform, and so you can see all that expertise they're bringing onto this product that's actually running on the cloud. And it's completely cloud hosted, which means you don't have anything to download, nothing to install. All you have to do is fire up your browser or any other internet device, any other internet access software, and you can run the product from anywhere, 24/7, anywhere in the world. And it runs on PCs, Macs, phones, almost any device that supports a browser or any internet access software. It also handles parts, assemblies, drawings, the traditional, the 3 modes that you have in SolidWorks, but they've also added built-in data management, which is very powerful. People might know of this as PLM and other systems. If you're used to product lifecycle management software in SolidWorks or some other solid modeling system, you are aware that you would need to purchase extra software and integrate both the modeling software with the PLM system. But what Onshape has done is they've actually bundled the data management portion into the product itself. So they've learned a lot of these lessons from their SolidWorks, stint, and put this into this new product, and it's really powerful, and it's worth taking a look at it if you're using SolidWorks or any kind of solid as well, or even any kind of modeling that involves solids. The twist to that, a little bit of the subscription model is different. I'm sorry, the licensing model is different. It's a subscription based, so you typically buy an annual license, and you can go monthly as well, but I think they're de-emphasizing that licensing model. And also, just like in SolidWorks, they're building an app ecosystem for add-on applications that includes CAM, FEA, rendering, and anything that might down the road might be piggybacking off the Onshape CAD system. And we are one of the first, actually, we are the first production CAM product vendor to be on their app ecosystem. And so we wrote this product called VisualCAMc. If you want to move to the next slide, Uday. And this product is basically our desktop technology, all the algorithms that we have developed over the years on the desktop, and we have wrapped it up so it will run on the cloud. It's a full production milling solution. All the elements of our desktop technology are in this product. And again, it's a full cloud application, no downloads and no installs. The only difference between this and the Onshape product is we are web browser hosted user interface. You cannot run it in a phone. I mean, if you have a browser that runs on a phone, you should be able to do it. But any PC, whether it's a Mac or a Linux or Windows machines, any machine that can host a browser like a Chrome browser or Firefox or Internet Explorer, those things of that sort, you can run this product from anywhere in the world. It's also a subscription licensing model, very similar to the Onshape product. We offer monthly subscription as well as yearly subscriptions. Currently, we support 2.5 axis, 3 axis, and 3+2 axis milling, as well as drilling operations. The plan is eventually to get all of our technology that's running on the desktop to the cloud. And one other note that I should mention, again, just like Onshape is SolidWorks 2.0, VisualCAMc is VisualCAM 2.0. We've learned a lot of lessons from the user interface and the usability of our desktop products, and we've distilled all of that into this system on the cloud. So the user interface is a lot more streamlined, and I would say more user-friendly from our desktop systems. So if you're interested in looking at these products, I would suggest the best place to go is onshape.com. You can go to onshape.com, and you can request a trial. They have I believe they have a 30-day trial or 15-day trial. I'm not sure. You have to check that. Go in and request a trial, and you can, again, like I said, there's nothing to install, nothing to load, so you'll be able to run it right away. And the way you get our product, Uday will be talking about it. I'll actually show you how to get it. You go to the app system and load our product, VisualCAMc. So that's a brief overview of both Onshape and VisualCAMc. And yeah, that's the app system Uday is showing. This is the VisualCAMc product you can download. You have a 14-day free trial. And then the monthly subscription for this product is $99. Then you can save money if you get the annual subscription, which was from $9.99. So that's a brief overview of both of these products. I urge you to take a look at it if you haven't seen it. If you haven't heard about it, it's a really good opportunity for you to learn a little bit about what we consider is the future of CAD/CAM. Maybe you're not ready to move here right away, but I think is we believe that this is going to be the future of CAD/CAM, just like you had Office move from the desktop to the cloud, and a lot of companies are doing that. We also believe that the desktop will coexist with the cloud, so it's not like we're abandoning the desktop. We are developing both in tandem, and there's unique strengths for developing a product on the cloud, and there are unique strengths on the desktop. So we are continuing to leverage both of those, and we will continue to do so in the near future. But this is a really interesting technology that I urge you all to take a look at. So without any further ado, I'll hand it over to Don to talk about some of our customer success.
Thanks, Joe. Uday, you can go ahead and go to the first slide. I want to take a minute to talk about two users that have started using VisualCAMc and Onshape and have experienced great success doing so. The first one here is De La Rue Authentication Solutions, and we have a success story in print and a video of the success story. There's a link for the printed version of the success story at the bottom, and I think, Joe, you're going to paste a link to the video in the chat. De La Rue, if you look at this emblem here on the top right, that is what De La Rue Authentication Solution does. Now, De La Rue is a large global company that they interact with a lot of banks and security mechanisms of that nature. The authentication solutions part of it makes those laser imaged appliques for authentication labels that companies can place on products. And those are laser imaged on 1,000 thick pieces of polymer. And can you think about the apparatus and the technology required to do that? It's very proprietary and no one else does it. So as I mentioned, they're a UK global-based company in business for over 200 years. They work with central governments and banks on security measures, like on banknotes and other types of security and all the management that goes with that. The Authentication Solutions division creates the authentication labels that are laser imaged on these appliques. And think of all of the mechanical components and component mechanisms to actually make this happen is what they do. John Humphreys, we sat down with John and talked about De La Rue Authentication Solutions, and he is the engineering manager for the past 18 years. And he is a longtime user of SolidWorks and with VisualCAM for SolidWorks. And they use SolidWorks and VisualCAM to develop all of the developmental designs and the prototype designs and the production designs for this production system to make these appliques. And in the last 2 years, John moved over to to Onshape. He liked the Onshape model, the fact that you don't have to have any IT people. His big comment was that he doesn't have to have anybody come in and do updates or manage the software or do anything of that nature. It's all done for him on the cloud, and that's one of the things that he really liked about it. And plus, the first thing he started looking for when he went to Onshape was how was he going to cut parts. So when he saw that MecSoft had a product for Onshape, he was one of the first ones to sign up. And currently, he's using both products. He's using Onshape and VisualCAMc, and he's using SolidWorks and VisualCAM for SolidWorks. So he's in a phase where he's using both, and he's got about maybe 1,000 components migrated over to Onshape, and he cuts all of his developmental and prototype components in-house using VisualCAMc, and still uses VisualCAM for SolidWorks and SolidWorks. But he's in that middle transition, and that's why it's so interesting about this success story, because he's finding success in both technologies, and that's what's interesting about it. Now, hardware-wise, they machined assemblies to do this are rather small, if you can think about making these appliques and lasers. So it's a very compact system, so the components are relatively small. So he uses a Roland MDX 540. He has a CNC Master Supra knee mill, an X-Carve CNC router, mostly for just wood, and he has a couple of custom designed CNC routers that they have designed, put together internally, that he's using the product with also. So I encourage you, this case study, success story is already written. It's on our website. I encourage you to go read it. And there's a video that goes with it. If you don't like reading, just watch the 10-minute video, and it goes over all of what John's doing with VisualCAMc and with Onshape. And I think you'll find it.
I just, hey Don,
Yep.
just a note, quick note. I just posted both the link to the case study as well as the video, the YouTube video link on the chat window. So if people are looking at it, they can get access to that.
Okay. Uday, if you want to go to the next success story. And here's a slide for a comment from John Humphreys. This is just one comment. In our discussion we had with John, he had a lot of good things to say. We obviously can't say everything that he said, but the case study does have all of his comments in it. One of the comments I wanted to hear is that he's really happy with VisualCAMc and the fact that he can do development and prototyping, design and machining in-house and make changes within a day and have a new part machined and they're ready to go. They save a lot of time, especially in development when you go through a lot of iterations of designs, and Onshape is really good with that as well as far as the product management. So the two go together very well, and that was one of the things he was very happy with. And the fact that because he already knows VisualCAMc for SolidWorks, moving and working on VisualCAMc, basically almost a zero learning curve. I mean, he was just up and running immediately within a day. So that was the comment that I wanted to show from John. Okay,
Another thing.
Go ahead, Joe.
Yeah, before you close it out, the other thing I would like to add is Onshape is really good for collaboration, which means you could have people in different parts of the world looking at the same part, working on the same part, and the same thing with VisualCAMc. What you can have two users looking at not simultaneously, but you can look at the same part. You don't have to do any emails of the part files. They access the exact same database from different parts of the world. So it's almost instantaneous, all these changes that you might be working on that the other person on the other end of the world might see. So that's an important distinguishing factor of Onshape and VisualCAMc as compared to the desktop products.
And Joe, that was another thing that John mentioned was, since they're a global company, they do collaborate in different parts of the world. And that was another one of his great benefits that he commented about as far as using Onshape and VisualCAMc.
One thing I could add here is this is like, working on a document, multiple users collaborating at the same time. Consider this is the CAD, Google Docs for CAD or something similar to that. So everybody can work on the same document at the same time while you're designing it. And then you don't have to email, just share a link, how you share a link to any document.
Okay. This next user, West Penn Manufacturing, they're in Crescent, Pennsylvania. Uday, we can go to the next slide since all of the talking points for this one I was on the next slide. They're a relatively young company. George Bohr is a chief operating officer. We sat down and talked with George just recently. He has a lot of years in manufacturing, worked for a lot of different companies in the shipbuilding, in a lot of different industries. And he decided to just let it go and start his own company, him and his family. So it's a family-owned company, about 5 years old. They have about 25 employees, and they're a build-to-print manufacturer. So what they get, all they get is a PDF drawing. And it's got the specs and all the information they need to quote the part and to manufacture the part. So they get take that print and they model it in Onshape. And they've been with Onshape for about 1.5 years, and they use it exclusively now. So they do a lot of, not really complex, but some of the parts are complex. A lot of sheet metal parts, a lot of drilling, a lot of pocketing, and they do production anywhere from 1 or 2 prototype parts up to 1,000 or more annually of some components. And they have over 1,000 different parts that they're actually in production at any one time. So, like I mentioned, if you could go back 1 second, I wanted to, Uday, go back to the previous slide for just a moment. George, his previous experience has been all with SolidWorks. In his previous CAM experience prior to Onshape, he was using SolidWorks, he was using Pro-E, and also using MasterCam and GibbsCAM for his machining. And the type of hardware he uses in-house, the typical manufacturing hardware you expect: punch presses, plasma cutters, water jets. But he also has 3 Haas VF6 machining centers, and he keeps them running pretty much 24 hours a day. And Uday, if you want to go to the next slide. One of the interesting things about George in relation to John is that George has never experienced VisualCAM or MecSoft products before now. He got the product, got VisualCAMc about 1 year ago. About 6 months after he got Onshape, he saw that we had a plug-in for Onshape, and he got on board of that, and he hasn't looked back. So he compares it very easy to use, you can imagine, in comparison to MasterCam or GibbsCAM. And the fact that it's on the cloud, it's even better. He can collaborate with his vendors and whatnot. And he really likes the ease of use of VisualCAMc. Now, this success story, we're working on it right now. We don't have a PDF that you can read or a video yet, but we will have that. And if you keep track of our emails and stuff and our website and our case studies and stuff, you'll see that that one will be coming out very soon. Joe, Uday, I think that's all I wanted to say.
Thank you, Don. Thank you, Joe. Folks, we are now ready to take a look at VisualCAMc for Onshape. I'll show you how to get the app and how we can work inside of Onshape. We can run VisualCAMc. So as Joe and Don pointed out, VisualCAMc for Onshape is a 100% cloud-based CAM solution. So you don't need to install or download any products. It completely runs off of your web browser. So if you notice, I'm running this on a Chrome browser. So once you have signed in to Onshape, you can go into your app store and then you can subscribe. There's a free 14-day trial available. You can subscribe to it, and then you can sign up for the monthly or annual subscription. So I currently have VisualCAMc opened up in here. So Onshape signed into Onshape right now, and you can see all the documents are listed in here. So you could create, you know, a part. So you can just select you want to create a document where you can basically give it a name for the document. You can basically draw parts, create drawings, and assemblies as well. It's all tab driven. As you see down at the bottom, you have different tabs. So you have a part studio where you can model parts. You have all the drawing tools. You can keep adding new elements like create a part, assembly, drawing. And how do we go about loading VisualCAMc is you click on the add insert element, add application, and select VisualCAMc. So what I'm going to do is dive into a part that has already been designed, and I'll give you an overview of the interface of VisualCAMc, and then we'll take a look at how we can program toolpaths for the parts that you design or import into Onshape. So what you're looking at here is an assembly of a 3D printer, and you can see there are several components, hundreds of components in here, and everything is being 100% done on the cloud. So you can see in real time how fast it is. So once we have an assembly here, we can see there's several different tabs. Each of the components that you have are on different tabs in here. I can navigate through the tabs. So today I'll be focusing on machining 1 or 2 of these components from an assembly. So I'm going to right click and say go to this particular part. So the connector plate is what we're going to be focusing on from the assembly. And this part is prismatic. As you can see, it has a bunch of holes, slots, and a profile to be cut out. So I'm going to go ahead and insert an element, add application, VisualCAMc. So that's how simple it is to load VisualCAMc for Onshape. So this will be loading the VisualCAMc app in here. And once the VisualCAMc app shows up, you can see it shows up as a new tab, and the tab is automatically created and it appears within the same document. So this is not a file-based system. This is a document. So there's no files. Everything is in a document format. So I'm going to look for this file here. I can load files. I can do a search. I can load a document. And I'm going to just load this part, which is the connector plate, which we would like to program today. So as you will notice here, the VisualCAMc interface is loaded within Onshape. Right across the tab, you have 3 tabs. The Home tab, which allows you to load a part. You can save all of your CAM programming to the same document in Onshape. Preferences allows you to customize your colors, toolpath, post-processor settings, and the global system settings. The Mill tab gives you the control to define your machine, select your post-processor, create your stock, and your workflow of creating machining operations. We have a wide range of methods in 2-axis, 3-axis, whole machining, and of course, knowledge bases. The browser interface is very similar to our desktop product. We have two, we have the machining job, similar to your machining browser. And then the tools tab allows you to manage all your tools. You can define tools as you create these projects. Tools of different types can be created. Flat mill, ball mill, corner radius tools. You can also load a library of tools in here by just going to import library, and you can pick a library of tool that you'd like to load and then select open. And then you can simply drag and drop the tool from the library into the tools and document, so the tools that you need to work on this particular part. So as simple as that. So we loaded some tools in a library. Now the Analyze tab over here allows you to check for dimensions. So for example, if I would like to figure out what would be the diameter of this cutout in here, I can measure arc diameter and just select the edge, and it measures the diameter of the arc. I can measure the hole diameters. I can measure linear distances. You have analysis tools in here as well. Okay, so I'm going to switch back to the Home tab, and you'll now notice that we already have a part loaded, and we'll go through the workflow for programming this part. So from the Home, I'm going to switch over to the Mill tab. And the first step is to define the machine tool coordinate system for machining. So the blue arrow represents your Z, the red representing the X, and the green, the Y. So we need to orient the coordinate system for machining. So in this particular part, I would like my Z to be normal or perpendicular to this face. So I can use the controls in here to rotate it. Very similar to how we've done in the desktop products. The interface looks very similar. So I'm rotating the Z coordinate and then the X and the Y. I'll save it. So the coordinate system for machining is oriented. So we want a machine looking down from this face. In the next step, we can select our post processors. The standard library of post processors are included in VisualCAMc. You can just go to load from defaults, and you can select a post processor from your list. You can have 5 of your favorite posts loaded automatically as presets. So if you have 5 different machines or you want to post them to, you can set them up here. You can also bring in your own customized post. If you're using our desktop product and we help you customize a post, you can click load from file and import those post processors into your post processor list, and they'll automatically appear over here in the list. So for this particular example, I'll just go pick a FANUC post processor. The post is defined. In the next step, we can define our stock geometry. You can do box, part, box, cylinder, or part, cylinder stocks. I'm going to go with a part box stock, and I'll specify an offset in here, and then we'll give it a Z offset of 20 thousandths. So we define our stock, and the stock appears right on top of your screen, and right in the headset display, you have controls to zoom in, zoom out, change the view orientation. So all of these controls similar to our desktop product. Now, the first thing we want to do is go ahead and establish the work 0 location of your program 0 or work coordinate offset. So we'll choose work 0, and I'm going to choose set to stock, high as Z, southwest. You can see how nicely the dialog overlays on top of your machining browser, so giving you more space in the viewport to work with your geometry. I'm going to select save. So the work 0 is now set to the top of your stock material, the southwest corner. And we'll go through some toolpaths programming workflow. We'll start with 2.5 axis facing. And this automatically displays your facing operation dialog. You can pick your tool, establish your feed speeds, establish your clearance definition. If you notice the interface, it looks very similar to our desktop product. It has all of the controls that you see in our desktop product, but it's completely on the cloud. And everything is being done real time on the cloud. So the browser is just for you to interface with it. The backend servers have the ability to scale up and scale down depending on the complexity and the demand of a work is required. I'm going to choose a cutting pattern in here, specify my step over distances. In the cut levels, you can specify the depth of cut, and then select generate to generate the toolpaths. So the toolpaths are generated on the cloud and delivered back to you right here. We'll save. So the facing operation has been generated. You can right click and then select simulate to run a verification. And you can control the simulation speed using the controls right at the top, and you have all of the simulation controls. Once the simulation is completed, we'll exit the simulation mode. We'll go ahead and program a few additional operations. So I'm going to program the holes using hole pocketing. Pick the tool, select the features. I'm just going to pick an edge, set feeds and speeds and clearance, very similar to how we programmed on the facing operation. You can specify the depth of the hole. You can specify the additional cutting parameters in here as needed. You can do a sorting, apply your entry and exit parameters in here. All of the controls you see in the desktop product are available on the cloud as well. And then generate. So there's our toolpath for the hole pocketing operation. Now I would like to repeat the same for the other two holes. Rather than having to recreate it, we can do a copy paste. Right click copy, right click paste. So we made a copy of the operation, double click to edit, and just go pick the features from the model. I'm going to change this to a smaller tool. Then all I'm going to do is change my cutting depth in here for the hole. And if I need to measure how deep the hole is, I can just go to analyze and use the distance tool. And I can pick the center of the top hole on the counterbore and the next one, and gives you the depth right there, 0.0787. So I can just change the depth right in here and then generate the toolpath. So I could go through the process of programming the additional holes. Let's go ahead and program the slot in here. So we'll switch back to the mill tab, do a slot machining using slotting operation. I'm going to use the 1/4 inch tool, and right click on an edge, automatically change the selection. If you want to drop something, just do a space bar. It'll drop all your selections. Right click on an edge, change it for you. And then you can specify the cutting parameters, choose the type of cut, depth control right here, and then generate, create a slotting operation. Now I can repeat the same slotting operation for the smaller slots by just making a copy of the operation. Copy, paste, edit the operation. You can swap the tool out. And all I'm going to do is swap the features now. Right click on an edge, change it up, generate. Now I'm going to do some drilling operations on this part. Go to hole machining, drilling. We'll select the tool for the drilling, number 7 drill for these holes in here, and then just select the hole features. You just pick the top edge on the hole features. And define your parameters like the depth. You can apply the type of drill, whether you want to do standard drill, deep drill, countersunk, brake chip. You have all of those drill cycles available. You can apply any sorting routines, generate. We can repeat the same process for drilling the smaller holes, but I'm going to skip them here. Now the last thing I want to do is cut the profile around the perimeter of the part. So we'll do that using a 2-axis profiling operation. I'm going to use the 1/2 inch tool If I pick the 1/2 inch tool, the cutter might be too large for this particular cutout in here. So I'm going to switch it to a 1/4 inch tool, and I will just right click on this edge, and you'll notice that it automatically auto chains. You don't have to go and pick each and every edge from the model. So just right clicking on an edge will pick all the edges for you, makes your programming workflow a lot simpler. You can define your cutting direction, the site to cut automatically based off the 3D model. You can specify your cut depth. You can even pick the depth from the model. Just use the pick option, pick a top edge. You can pick anywhere along the bottom edge right here. And the total depth is determined. If you need to change the depth in here for any reason, you can go back and change the total cut depth as well. You can break it up into multiple passes, apply any sorting if you're doing multiple profiles, choose your entry and exit parameter, and then generate, create your toolpath. So we've now generated all of these operations in here. If you go ahead and highlight the setup, it'll give you an estimated time for machining this part. And then we can do a simulate all, right click and simulate. It's going to simulate through each and every operation that you program step by step. And you have the ability to change the simulation speed, have it go faster or slower. And all of this is being done on the cloud. Folks, if you do have any questions, please feel free to post those questions in your questions panel. So we are simulating the slot operation in here. You can see the progress of the simulation. The smaller slots are being simulated. And anytime, if you want to do a pause or just want to stop the simulation, you can use the controls in here to pause it, and then you can exit out of the simulation mode as well. So we're looking at the simulation of the drill operations in here. And then finally, the profiling operation, where it relieves the material from the stock. So the simulation has been completed. I'm going to exit the simulation mode and then go to the setup. And now we'll look at post-processing. So to post-process, right-click on a setup, and you can select post-process, or you can right-click on a machining job and do a post-process, or you can even individually select one or more operations to post-process. So once the operation is post-process, it's going to automatically download it to whether you're running on a PC or a Mac or a Linux. It'll download it for you, and then you can open it in a viewer. It could be a text editor or any application that you have mapped it to open it right there. So there's your posted output file, which is now ready to be transferred out to your CNC machine. Now selecting Save on the Home tab automatically saves all of your programming CAM data into the same Onshape document, and the CAM data is saved as you created in a new tab in VisualCAMc. And you can have multiple VisualCAMc tabs within the same document. So if you have multiple parts or multiple iterations of the different part, you can program and save them within the same document. So you're not creating multiple files, you're just adding a new tab for each document. Now, one of the nice things I would like to point out here is all of these operations that we programmed in here, we could now save them out to a knowledge base. So I'm going to go into the Mill tab and then choose knowledge base, save to knowledge base. So the entire workflow of machining operations is now saved and downloaded automatically to your computer. So now let's go back and switch back to the main assembly in here. So I'm going to show you how we can apply this knowledge base when programming one of the other components on this part. So I'm going to take this mount plate in here, right click, and I'll switch to the mount plate part document in here inside of Onshape. And the workflow is very similar. I'm going to load VisualCAMc. So once I have VisualCAMc loaded, I'm going to load the part. And you can either load the part by looking through the list for the part or just entering a name for your part. I'm just going to search by the name. So the part is now loaded. The next thing I'm going to do here is go to the Mill tab and then load my knowledge base. I'll load the knowledge base which I just created from the other file. And you can see the entire workflow is now loaded. If you want to delete something, right click and delete, we'll delete it. And then the workflow is very similar. Establish your coordinate system for machining. Go ahead and select your post processor. So I have it, if I want to change it, I can pick a different machine. Go ahead and define my stock material. And then I can just edit my work 0 under setup, set my origin, save it. I'm going to regenerate my first operation facing, and the toolpath is generated. If you need to make any change to the parameters, change your cut direction, any of those, just right click or double click to edit it, and then generate the toolpath. So the knowledge base brings in all of your information about your feeds and speeds, your cut depths, cutting parameters. All of this is saved in the knowledge base, which makes your programming workflow a lot simpler. Now I don't want to use any of the hole pocketing operations on this particular part. I'm going to select these two, right click and do a delete to remove it. I'll edit the slotting operations in here and just basically chain each of the selections. Right click on an edge will chain the selections. Pick a tool for the slotting, generate. So the slotting toolpath has been generated. You can toggle the visibility of your toolpaths, the coordinate system, all of the controls can be found right in the browser. I'm going to get rid of the second slotting operation, and then we'll apply the drilling operations in here. I can just go pick the holes for drilling, generate the path, and finally I'm going to do the profiling operation. I'll do the profile operation for the inside. Right click, selects the chain, we'll pick the smaller tool, generate. So since I've set it to use determine using 3D model, it automatically figures out the cut needs to go on the inside. If you would like to make any changes to your entry and exit parameters, you can pick those, make those changes in here, and then update your toolpaths. They're all updated in real time. Save it. And finally, if you want to do a perimeter cut, make a copy of the operation, paste it out, edit the operation, right click on an edge to select the chain, generate it. So within a few clicks, you can generate your toolpaths, save your work, and the CAM data is automatically stored in the VisualCAMc tab within Onshape. Now, one thing I want to point out is the model units. Depending on whatever you have set in your document in Onshape for the units, workspace units, VisualCAMc will automatically inherit those units. If you're working in inches, your CAM will automatically load in inches. If the model was defined to be in millimeters, it'll be in millimeter units. You can see the units displaying right in here. Okay, folks, now the next thing I want to talk about is how we can program some 3-axis toolpaths using VisualCAMc for Onshape. If you do have any questions during our presentation demonstration, please feel free to post those questions in the questions panel. So I'm going to take this mold cavity in as an example, and we'll show you you can work with simple or complex geometries with a breeze using VisualCAMc for Onshape. So I have a part modeled in Onshape, and I'm going to go to the VisualCAMc tab. I've already loaded the part in VisualCAMc just to make it a little faster for the purpose of our demonstration today. So the part is automatically going to preload since it was loaded and saved on the VisualCAMc tab, so you don't have to go through the process of reloading the part. So the part has been loaded, and this document is in millimeter units, and you can see that the model units is set to millimeters in VisualCAMc. And I'm going to go into mill, and in the tools tab, I have 2 tools already saved in here. And then I'm going to define the workflow very similar, define the post processor in here. I'll choose Haas as the post processor for the discussion here today. We'll select the post. We'll go in and define the stock material. We'll do a box stock. And now we're ready to generate some toolpaths. So first step, define the coordinate system origin for machining, and then the work 0. You can output your work offset number. Hit save. Go to tools tab. You can load a tool library if you want to bring in your own tool library in here. And you can even drag and drop tools. If you want to do a facing operation, you can drag and drop a facing face mill cutter. You can drag and drop additional tools as well. Now I'm going to go directly into some 3-axis toolpath methods. So under 3-axis menu, you'll find Z-level roughing, which is similar to our horizontal roughing in our desktop products. Z-level finishing is equivalent to horizontal finishing. You have parallel, radial, and spiral machining. So let's start with the roughing process. We'll do Z-level roughing. We'll pick a tool for it. We'll use the 1/2 inch flat or 12 millimeter in this case. Set feeds and speeds, clearance. In the parameters, you can establish your cutting parameters where you can set your tolerances. Start to leave. Under cut levels, cut parameters, you can specify your cut patterns, your step overs. Under cut levels, you can specify your step down controls, control your entry and exit. So you have all of the controls that you've seen in our desktop product on the cloud as well. So you can control the ramp height, the linear extension distances, any advanced cut parameters, and all you do is generate. So you can see the tool path is being computed on the cloud. And as I pointed out earlier, depending on the complexity involved, it automatically scales up and scales down the servers that are required for process your tool paths. So you don't really need to have a very powerful hardware running on your end. It could be, an ordinary, even like a Chromebook. You can run it on a Chromebook, which is basically, just a very simple computer. And as long as you have a web browser, a decent internet connection, and a WebGL, that'll work for you. So the tool paths have been generated in here. You can toggle the visibility of your tool paths. We're going to run a simulation, right-click and simulate. So there's your simulation for the horizontal roughing or Z-level roughing operation. I believe there was a question about loading a desktop tool library in VisualCAMc. If you export the tool library in a CSV format, you should be able to import them into VisualCAMc. At any time, I could do a pause, simulate to end to run through the simulation. The simulation has now been completed. I'm going to exit the simulation. And we are now ready to program some finishing operations. So we'll go to, from roughing, we'll go into 3-axis finishing. We'll do a parallel finishing operation. We'll pick a ball mill tool for it, specify the parameters for cutting, put in the step over, and then generate, create your tool path. Now, if you'd like to contain your tool paths to a specific area, you would do it similar to how you do it in our desktop products, where you can basically pick a region to contain the tool paths by selecting a set of edges in here. So if you want to contain it just to this area here, I can just go pick these edges and then do a generate. Now the tool path stays contained to an area. Or if you just hit a space bar to drop all of them and hit generate, the tool path will be generated for the entire model. So we now generated a parallel finishing tool path. I'm going to add a Z-level finishing tool path in here. And I'm just going to right click on the bottom edge. So it picks the chain for a containment boundary. We'll use the same ball mill tool. I'm going to use a step over of 10% and generate it. And it's all happening in real time on the cloud. And you can see the task progress manager shows the status. It's generating the tool path. Once the tool path has been generated, it's receiving the data. Once the data has been received, you can see the tool path right on your screen. Any change that you make in here will automatically be updated. So I can change the tool action control from retract to follow containment. Selecting generate will update the tool path, and you'll see it'll minimize a bunch of these transfer motions, retract and transfer motions. So once you have all of your machining operations programmed and generated, you're ready to post-process it, very similar to how we did on the 2-axis and a 2D part. So I'm going to hit save, select the setup to estimate the time. It's about 45 minutes to cut this part. Right click and post-process is automatically going to go ahead and download the posted output file onto your desktop computer in here. If you're running Windows or a Mac, it'll just download it and automatically use the name of the file, the document name, and the part name. And there's your posted output file ready to be sent out to your machine tool. Now, before I wrap up, one last thing I want to talk about is the associativity with the CAD geometry and how VisualCAMc handles that in Onshape. So I'm going to go back and switch over to my document screen in Onshape, and we'll take an example for that. So here is a part, a 2.5 axis prismatic part, which has a bunch of operations programmed already. If I go to the VisualCAMc tab, you'll see I have a facing, a pocketing, some whole operations on it on this particular part. It's already programmed. I had it programmed earlier today, and you can see all of these operations in here. As I select them, it automatically previews the toolpath on each of these operations I select in here. So let's say there's a need for a design change, and I'm going to go back to the Part Studio in Onshape, and I want to make a change. So I'm going to right click, and I'm going to change the sketch dimensions in here, and I will modify the size of the pocket. I'm going to edit that, change the pocket size in here. I'll modify it over here too. And I'm going to update. So now you can see that the pocket was shrinked a little bit. I made it wider, but reduced the height. So I'm going to go back into VisualCAMc tab, and you'll notice that it automatically identified the change in the geometry, and it reloads the data and also gives you a prompt right here. It says CAD data was reloaded due to geometry changes. All I need to do is right click and regenerate, and the toolpaths are now being updated. So if you added a new element or modified it, you just have to go back and maybe reselect some of the regions in here. Right click and chain will let you reselect it. So the geometry is automatically loaded, checks for changes with the CAD and reloads it for you, making your programming workflow a lot easier, so you don't have to go back and reprogram it each time when you make a design change. Folks, if you do have any questions at this point, please feel free to post those questions in the questions panel. And one of the things I wanted to point out here in the webinar is we have extensive help and help topics that are available in VisualCAMc for Onshape. So if you go over to the Home tab, you'll see there's a drop-down menu for help. And as you select help, this displays the online help for VisualCAMc. And you can go to any of these topics in here to learn more about it. You can search the help topics as well. So for example, you want to learn about the home toolbar. Selecting the topic in here will display the home toolbar. You can even go into a help topic directly from one of the dialogues. So when I edit a pocket operation, I can click on help, and this will bring up the context sensitive help for those topics directly in here. So the help is extensive, and you can see when you click and expand it, you can read about each and every topic in the help. Now, there are other useful help tools in here. We have extensive videos for VisualCAMc. You can click on videos, and that'll take you to our YouTube channel where you can watch all of the videos on VisualCAMc, and these are constantly being updated, so you'll see newer videos being added periodically. To access the help system, you can also give us feedback and also learn about what's new in VisualCAMc. And when there's a new update pushed out, everybody will be on the same latest update, so you don't have to download or install or manually update it. So you'll notice that the new updates, once they get released, the What's New document gets published on the website, and you can see the ability to now store and load machining operation templates. Knowledge bases were recently updated into VisualCAMc, and we do updates in sprints, and all of these updates are seen in here on the What's New tab on the website right here.
Yeah, our average update interval is about 2 months right now. So every time we have something new that goes through QA, and after we make sure it's working, we push it out onto the VisualCAMc main servers for all of our users to access it. So, and that's how we do updates. We don't have version numbers like in the desktop. So it's a constant update system, and that's very typical also of Onshape as well. They update their product very similarly also.
Thank you, Joe. So with this, I would like to wrap up my demonstration and hand it back to Joe.
Yes, one of the things I also want to emphasize is talk about, maybe not emphasize, is the interoperability between your desktop systems and the VisualCAMc. So currently what you can do, there are two things that you can leverage your existing desktop, knowledge and also the data. Post-processors, they can be loaded. All the desktop post-processors can be loaded in VisualCAMc. In fact, VisualCAMc uses the exact same post-processors as the desktop systems. So they're completely interoperable. The second one is the tool libraries. If the tool libraries are saved in the CSV file format on the desktop system, that can be loaded here. So you're not going to lose any of the data that you have saved. And currently we are also, there's no exchange of part file information from your desktop or toolpath information or parameter information from your desktop system to the VisualCAMc system. But that's something that we're looking at, and we're hoping to get that, once we get the technical details ironed out, we're hoping to roll that out in one of the future updates. And that's pretty much it. We'll wait a few minutes for any questions you might have. And if there are no more questions, thanks for the very good demonstration. And thank you all for attending. And as you can see, this is a product in constant development. And so your feedback, we appreciate all the feedback that you can give us. And I would encourage all of you, our desktop customers, to take a look at it. This might not be appropriate for you, but it also might be appropriate. If you're getting somebody in your company who wants to run a simple project for maybe a couple of months, and he doesn't want to acquire another seat of our desktop system, this might be a good option for you. Because the cost of entry into the system is very low. You can do the monthly subscriptions, and so that's something you can use on a as needed basis. So that's one of the reasons we wanted to show this to you. And also, like I mentioned before, this we believe is going to coexist with the desktop systems because of all the advantages of having something on the cloud. Of course, there are disadvantages as well. What happens if your internet connection goes down? Things of that sort, you'll have to worry about it. But also there's so many advantages of having a system on the cloud that it's definitely worth a shot, worth taking a look at. So again, thank you all for attending. We will, as mentioned before, we will send out the webinar recording link as soon as possible. And then please feel free to contact us. Uday, if you want to put up that slide, the last slide, where they can give us the contact numbers. Yeah, either by phone, fax. I don't know if anybody uses fax anymore, but you can also use his email. Contact us by Skype or chat window. So again, thanks a lot, and see you next month.